All right, this is lesson 15, but we're going to get started with a little review. This review slide has some things on it that we haven't had, and I've explained that, so ignore this for now. That's coming later on down the road, but I do want you to start with this right here. So if you would set that up on your board and work that problem out, and we'll go over it in just a second. Oh. Unfortunately, there's not a way to check your answer, but keep going. Well, there is a way. Alright, so if I jumped in here to get caught up, I would encourage you, if you're forgetting the step of on the second row, putting that 0, just keep drawing that shape, and hopefully that will remind you. We're going to go 8 times 6, which is what, everybody? 48. That slowed some of us down, but it's 48, so put the 8, carry the 4. 8 times 5? 40 plus 4 more is 44. So your top row would be 448. Okay, now we're done with the 8. We put the dinosaur egg. Okay. All right, so we're on to the 3. 3 times 6? 18. Put the 8. Carry the 1. 3 times 5? 15 plus 1 more, 16. All right, those words are in my way. So we're going to add those up. 8, that's 12, 10 plus 1 more is 11, and then 2, 2,128. Yes.
Can we share on this thing?
Yeah, I was just fixing to ask, so you read my mind. Okay, so if Charlotte wants to share a mistake that she caught. What did you catch?
I messed up on the numbers. I put 38 times 56.
You put 38 times.
The exact same thing,
But I put it upside down.
Like you put the 38 first?
Yeah.
Now, did you get the same answer, though?
Yeah.
Yeah. So it's not going to change your answer if you've done it correctly. I'm trying to get you in that habit of always seeing your bigger number on it, because sometimes when this number is big enough to have more digits than the bottom number, it will make it a whole lot easier if you've got that number on top. Yeah.
I did 36 times 56.
Okay. Just recopied it wrong. And how that happens so often. Yep.
I had it all right. Answers right. I did that. I did add them all right.
You messed up on the adding part. Yeah, even the adding part can get us sometimes. So be
I
careful.
messed up on the 6 plus 4 plus 1. I did 6 plus 4 plus 2.
Okay.
Even though I put the 1.
And even though you know what to do. Y'all know what to do at this point. It's just sometimes we don't see things right. We get caught in a small mistake like that. Yeah.
I didn't mess anything up. I just got it right.
Well, good. Good. Okay. Good for you. All right, we are gonna. Some of these words have just slid down, but the two questions we need are right there. So this is what we're going to do next. This number, let me write it larger just so it's easier to see. 345,299. So this big number right here in the middle. So put that on your board, and then we're going to round to the nearest 10. Round it to the nearest 10. Okay, so take your time and you got this. Find the 10 place. Look next door. Whatever shall we do? We don't need to be scared of them. We just need to know what to do. Okay? Once you know what to do, scary things aren't scary anymore. You know, once you have a plan, once you know what to do. So if it tells us to round to the nearest tens place, that's here. I think we all know that, and we all know to look next door. But this is a 9 talking to another 9. What in the world? Okay. What is this 9 going to tell this 9 to do? What is the rule? What does it have to tell it? What does it have to tell it to do, Faith? What? Go up by 1. Well, when you have a 9 and it goes up by 1, it changes to a 10. And then we have this 2-digit number, and we're like, what do we do with that? Well, okay. If you'll kind of write it up above. I know I'm having to squish it in there, but I write that 10 because this 9 is going to change to that 0, and this 2 is going to go up by 1. That's what that 10 causes to happen. Okay? And things don't normally happen to that digit right beside where we're looking, but it does when it changes to a 10. Because think about place value. When we started 4th grade, we had that place value chart, and one place would get too full, it has to carry over into the next spot, doesn't it? Okay, so we would keep the 3, the 4, and the 5, but that 1 gets added. It's kind of like carrying when you add normally. Okay, that 1 gets added to that 2, and it becomes a 3, and this 9 becomes a 0, and then from the arrow over, and we've only got 1 digit there.
All I missed was the 3.
Okay. Just knowing to go up with it. Did you put it as a 2 or something? Yeah.
I put it as 2. I got it right.
But because these numbers are so large, going up 1 is going to cause. It's like if we had the place value chart, too many dots would be in the that section, and it would go over to the next. Okay. All right. So that's a good one to have. It's not. That's probably one of your harder type of questions when you're rounding, but it's a good one for us to practice. Okay, let's move on. Oh, this is just a good day. Good day. All right, so I need you to clear off your board and put the top on the marker. And yeah, just put it to the corner out of your way where your hands aren't on it. Now, I told you earlier in the week, and it's only Tuesday, so maybe I said it yesterday, or maybe I even said it last week. Some new strategies are coming. New strategies are coming for working with fractions and comparing them, trying to figure out which one is bigger. We've had a whole list of strategies on the board, okay? And we will still use these, and we will still talk about these, but we're moving on to see a new strategy right now, okay? So I need you, there's a lot to this strategy, okay? Even though it's kind of neat, I really would need you to watch, okay, so that you get what to do. What I'm going to do is, let's see, I'm looking at the slide coming up. They just don't give us a whole lot of writing room, so I'm going to put it, once we throw away all this other stuff, I'm going to put it up here and just write it up here. All right. Well, what I need one of you to do is to remind me in the afternoon when we like get in from recess, or if we've had indoor recess, to say, hey, Miss Wendy, see if you can permanently throw those things away. And that's because by the end of the day, I forget that I've had to do this 47,000 times. But anyway, all right. So let's say the slide that they were going to show us has these two fractions, and that's going to drive me crazy. So go away. Okay. Come on. All right, it has 3/4 and 4/5. Okay, and we're trying to figure out, which one of those is larger. And both of them we know are bigger than 1/2, but, which one for sure is larger. Now, even though you might be able to think, hey, I can reason through that and kind of picture it on the number line, guess what method we're doing today?
What?
We are starting with the area model.
No.
Okay, yeah, we brought it back. It comes back all the time, doesn't it? And I know it's your favorite. I can see it in your eyes. Even if your mouth is saying, no, your eyes are saying, bring it, because we like the area model. Okay, so I want you to watch and see what this does. Okay, so I am going to need at first anyway, a completely separate area model for both of those fractions. So it does take a little longer, but that's okay. It is helping us to see what's going on. Okay, so I'm first going to make an area model just for this fraction. Pretty simple. I cut it into 4 pieces. I shade 3 of them. Okay, so cutting it into pieces, and then we'll do a little shading. Okay, and then we do one for the 4/5. I'm going to try to make it similar in size and shape, except, okay, here's where it gets different. This area model I have cut vertically. This area model I'm going to cut horizontally. So they look different. I could have cut this one horizontally and this one vertically. That doesn't really matter. I'm trying to show 2 different fractions, so I'm cutting it a little different. So I need this one in how many pieces?
4, 5.
No, 5 pieces on this one. 4 of them will be shaded. Okay. And so let's see. Picking a little different color. I don't guess it really matters. Just want it to show up well. Okay, so I'm going to shade 4 of these. Okay, now let me back up just a minute. I got ahead of myself. Let me back up just a minute. When we had our list of strategies on the board yesterday, because you might be wondering, why are we going back to models like this when we've already done tape diagrams, we've already done number lines? Why are we going back to drawing stuff? Because usually we start with that maybe and then we kind of go away from it. You remember our list? I just erased it a little while ago, and some of y'all were even saying it after I erased it. But it was, I believe, the first one on the list.
Same.
What was it?
Same denominators.
Okay.
Look at numerator.
Was it easier to compare 2 fractions when they had the same denominator? Was it?
Yes.
Absolutely. That's one of the key things that you guys are going to do, even on up into your older years of school with fractions, is you're going to find what we call a common denominator, a denominator that's the same, because once you do that, things get a lot easier. Okay? But look at these 2 fractions. Is it easy to go from 4 to 5 or 5 to 4 with multiplication or division, the way that we were doing it? You can't really do that, can you? I can't multiply 4 by something and get 5. I can't multiply 5 by something and get 4. I can't divide 4 by something and get 5, or 5 and get 4. So multiplication and division here that way does not work. it doesn't work with the numerator either. Because if that had worked, why do all this, right? You know, if we could have seen it sooner, an easier way, we might not need this model. But there is going to come a time, lots of times actually, okay, let me have your eyes, where you're not going to be able to do that. And so what we are actually doing is trying to create a common denominator. There is a way to do it, it's just a little different. Okay, and there's actually several ways to do it, and this is one that we're going to do it now. Now that I have these two models, watch what we do. We're going to take this model and combine it with this model. And then we're going to take this model and we're going to combine it with this model. Okay? So, let's try that. How many pieces do I have this way?
4.
Total?
Oh, 5.
5. So I'm going to take that and I'm going to add it to this. Okay? And this is another reason that we've done one of these vertically and one of these horizontally, because when we combine them, you want to be able to see both. Okay? A little easier. So if I know this is cut in 5 pieces, I'm going to add that over here. Okay? Okay? And this was cut into how many vertical pieces? 4. So I'm going to add that cut of those 4 pieces vertically, vertically over here. Okay? Now, let's see what we have. How many total pieces do we have here now? We've got 1. Did y'all know that y'all could count this way and count this way along the edges and then multiply those and you have the total number? So we've got 1, 2, 3, 4. 1, 2, 3, 4, 5. What is 4 times 5?
20.
20. So that's my denominator. And how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have a new fraction and it's rather large, but we have a brand new fraction. Let's see what our new fraction is over here. We've got 1, 2, 3, 4 times 1, 2, 3, 4, 5. How many are shaded? 1, 2, 3, 4 times 1, 2, 3, 4. What's 4 times 4? Oh, excuse me. I think I heard some difficulty answering that question. What's 4 times 4?
16.
Okay. Now we have 2 very large fractions. But what do you notice about our 2 new fractions? Yeah.
It goes 15 and then 16.
Okay, but what do you notice about our 2 new fractions in addition to that? Yeah. They have the same denominator. Mission accomplished.
Imagine if
Okay.
things are knocking
Now, I just made it a whole lot easier to tell which of these 2 fractions is largest. Okay, is 16/20ths bigger or 15/20ths bigger? If I've cut my pizza into 20 pieces and you're really hungry, would you rather have 15/20ths or 16 of those 20ths? 16. Okay. That one's larger, so therefore that one's larger.
So somebody already ate 4 pieces.
Yeah. This is not difficult. It just takes a little while. I'll say that. That's every strategy probably has its good things and its bad things. This is not the most efficient because it does take a little while. Okay. So because it takes a little while, would you like me to shorten it?
No.
Yes.
No.
Okay. Would you like me to shorten it?
No. Yes.
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 What? It is. It's just usually area models are not just this long skinny strip. There's a little more to them. So it is. It's very similar. Very similar. Okay. Now, is this a strategy you can use? You know when we listed our strategies and one of them was draw a model? This is definitely one we can use, but I do want to show you something a little different. Okay? Let's take 3/4 and 4/5, because I'll tell you guys, the model thing is not everybody's favorite. It does take longer, but one thing it does do is it shows you, kind of like our place value chart forever ago, it kind of shows you what is actually happening. Okay? So, with that thought, I'm going to shrink this a little bit. I don't want it to totally go away. Yeah, there's some other stuff hiding, isn't there? Okay.
That's probably why it keeps popping up.
It may be. I'm going to go here. Well. All right, so our fractions were, let's do this. So here's our area model. But right here, I'm going to put those fractions back, 3/4 and 4/5. Okay. Now, I want to tell you a story. Okay? So just, sit back, relax, but make sure your eyes and ears are with me. Okay? We like story time. Well, once upon a time in fraction land, there were 2 fractions. There was 3/4 and 4/5. And see, 3/4 and 4/5 live next door to each other. And you know how it can be sometimes with neighbors. Sometimes you're very, very close and you get along, but every now and then things happen and you don't get along. And they were having a rough patch. Just things weren't going so well between the neighbors. Okay. So, you know how sometimes when things aren't going so well between you and someone else, you get a little angry. And sometimes you can get so angry that you want to get that person, Maybe be a little ugly to them. Well, so Miss Fourth right here said, I'm going to get those 5ths. I'm going to get 4/5. So, one day when nobody was around, she snuck over to the house and she took the 5th there. And she took it, and she brought it back to her house. And then she hid it up in the attic. She stole it and she hid it. I know, the nerve. Now, story doesn't end there. Okay. So, Mr. 4/5 comes home. My 5ths have been stolen. What? What? It must have been that neighbor. 3/4. Dun, dun, dun. See, I need dramatic music here. It would make the story so much better. So much better. Okay. So, what do you think? He does? I'm not going to let her get away with that. Oh, no. So, he marches right over to, and they weren't around at that moment. And he steals their denominator and brings it back to his house. And he steals it and hides it in the attic. So now we have these 2 neighbors that, are not getting along. They've done ugly things to each other. And, what's going to happen to them? Well, what is 5 times 4, guys?
20.
And 5 times 3?
15.
And 5 times 3?
15.
Okay. I heard a 16 in there. I had to make sure we were.
That wasn't me.
And 5 times 4 is?
20.
And 4 times 4 is?
16. So we win.
So, they just had to become different fractions so that there was no longer this feud, if you will, between 3/4 and 4/5. So now all the 20ths, since they're kind of connected, they're all kind of the same, they get along. Okay? So we created 2 fractions with the same denominator. Oh, there's our strategy, and I keep pointing to this empty space because that's where we had written that.
Why did we erase?
Because I want you to start remembering it without it being on the board. But now we have a common denominator the same denominator, which makes comparing them super easy. Plus, we're all getting along and holding hands and singing la 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 together.
I thought it was
Okay.
fighting.
All right, no more fighting. No more fighting. So, with these two fractions, which one is largest?
6/20.
16/20ths, because I have more pieces of this size piece. Okay, but look. 15/20ths, 16/20ths, 15/20ths, 16/20ths. It's the same fraction. Okay.
Even though they got the bigger number, 3/4 that's the bigger number, it's still gonna be the exact same.
I guess explain what you mean.
Like they took the 5 away. They got 4. They got 5. They multiplied it by it. They still got the same. What's it called?
Okay.
Denominator.
Yeah.
Because they were multiplied by each other. It's just like with the area model. One of them was cut in fourths at first, but then we also cut it in fifths. We multiplied with the area
I
model.
thought it was gonna be equal.
Okay, this one was cut in fifths. Then we also cut it in fourths, which multiplied it with the area model. Okay? Yeah.
When are we gonna get to try that?
Very soon. Now, if you hear me say the steal it and hide it method, this is what we're talking about. Okay? So we are going to practice this a few times. Question? You have a question? Okay. All right. So we're not going to practice this.
Yes.
Is that something you can use? Yes. We're not practicing it, though. We're going to practice this. Okay? All right. So I'm going to just borrow some homework problems to give us an extra. Okay. I need that to stop. Okay. All right. Get your board. Get your marker. Here we go. Okay. Yeah. Leave it down. Okay. All right. So, because we're not practicing this, I wanted you to see it, but I'm going to move it over completely for now. Because I want you to still see this method. So let me separate. This is just something to help us. Okay, but I'm going to do these first few with you. We've got 2/7. So write that down. And we've got 3/5. We're trying to figure out which one is larger or smaller. And we look at it closely, and there's no way to get from here to here or here to here with division or multiplication. And so our strategy right now is steal it and hide it. And some people just jump right to this. Even if they can get from here to here, they might like steal it and hide it better, and you can jump right to that method. That's fine. Okay. So I know I told you a big, long story. You know why we do things like that sometimes? Sing a song, tell a story, because I hope you'll remember it. Okay? So as we talk through this, the 7 is going to steal this denominator and put it here. And then he's going to hide it in the attic. And that is so we can multiply it. And this denominator is going to steal this denominator and hide it in the attic. Okay? So make sure you've written that. Probably already have. Now it's just as simple. Do the multiplication and create your new fractions. So 5 times 2, 10. 5 times 7. Now look at that denominator. That's huge. Okay. If I had to cut my pizza in 35 pieces, they'd be pretty small. Over here, we've got 21 on top and 35. But the whole point was to get the same denominator, no matter how big it is. To get the same denominator. Because that's, now I can look at those and, I definitely know which one is larger. Let's say I had to cut that pizza in 35 pieces. Cut that pizza in 35 pieces, not 35 pizzas. 10 of those pieces or 21 of those pieces. Which one is larger? 21 for sure. Okay, 21. So you can draw that symbol there if you need to, but the main place to draw it is right there. Okay? All right. Any questions about that? Let's try one more together. I think you're getting this just fine, but
Yeah, I'm getting it.
All right. Let's go with 4/5 and 5/6. Using steal it and hide it. 5 steals the 6 and hides it in the attic. The 6 steals the 5 and hides it in the attic. Question? The 6 steals the 5 and hides it. Did I say something wrong?
No.
Yeah. Okay. So let's do the multiplication. 6 times 4 is what, everybody? 24. And what would be our new denominator? What is 6 times 5? 30. 5 times 5 is 25. And 6 times 5 is, again, 30. Now, I don't know about you, but when I first saw 4/5 and 5/6, I was like, oh, I could probably figure that out without this steal it and hide it. They're pretty close, but I did not realize they were that close. They're only one little piece away from each other. That's really close. If we were to put those on a number line, they would be so close we would almost wonder, does this one go first or does this one go first? You know, without having it really measured very specifically. All right, but 5/6 is larger. And because these pieces are smaller, you might have thought 4/5 was larger. Okay. All right, any question, what are some questions you might have about this method? Yeah.
It's easy.
Okay, so not a question, a comment. It's easy? Yes?
I like this method because it's like very easy and simple.
Well, like I said, you could draw the area models. They're kind of fun. It's kind of neat to cut it both ways and see it happening. But this is going to take you half the time, Okay. Maybe less than that. Okay. I'm going to give you one on your own. Can I ask you something real quick? Okay. Look at this problem. This is one that's already been worked out. What do you see happening that is something we've already been doing with fractions? Yeah.
You're doing the multiplication thing that we've already been doing?
Yeah. Haven't we already multiplied fractions using the same number in the numerator and the denominator?
Yeah, but we multiplied one.
We multiplied by like some different numbers. But guys, our whole point in doing this is creating a common, same denominator. Now look, 3/4 is equal to 15/20. We can do this because all we're doing is creating an equivalent fraction. We're creating an equivalent fraction right here from 4/5 to 16/20 by multiplying it by 4. And remember, several days ago, I let you pick any number you wanted to multiply by, Here, we just happen to be choosing the opposite denominator to multiply by. Yep.
This helps me because when we first started the multiplication, I didn't know what to multiply it by.
Yeah.
But when we started this, it said, you showed us that it's just taking the bottom.
You just grab that other denominator, don't you? Yeah, I think I would like that too. Because sometimes it is hard to decide, what do I multiply by? And this tells you, you just grab that other denominator and multiply by that. Okay, here's your question to do. What if you had 4/6 and 6/9? Okay. I'll give you a minute to work through that and then we'll talk through it. Question. It's going to make our denominators or our new fractions a little large sometimes. Large numbers. They may not actually be large. Got to know those multiplication facts. That's what's still slowing some of us down. Guys, if you're slowed down by multiplication facts, do you know that at home you need to be working on those? As you grow up and you get older and you get more mature and sometimes you've got to decide, hey, I need to do this on my own. My teacher didn't make me, my parents didn't make me, but I know I need to get better at this or that. Practice. Practice. Okay? All right, so what am I going to do here? Help me through this. Martin, what am I going to do first?
You have to multiply. You have to take away the 9 and take it to the 4 6.
Okay. So I've taken it.
And then you've got to multiply. And then put 9 on beside the 4 too.
All right.
And multiply it.
All right, so I'm going to multiply that and get 36 over what?
54.
54. Okay, so what's the next half of this? Ishmael, what's the next half? What am I going to do next? I'm going to take, yes. Okay, then I'm going to multiply here. And I'm going to get 36 54s. Well, would you look at there? Would you have thought that those two are equal? Just by looking at them at first? Would you have known that or thought that?
No, I would have never known.
Okay. But this method, as long as you know your multiplication facts, you're good on this. Okay?
Thought I wasn't gonna like
I would have never got that if we didn't have this.
You know, would we have put them on the number line in the exact same spot?
No.
Probably. We would have put them real close together, but not in the exact same spot.
That's
Okay.
why I like this method.
Yeah, I think you're liking it.
I think I'm liking this, but I thought I was gonna
Okay.
like it.
Now,
It's gonna be hard.
I'm glad you're liking it. I do want to show you one more method.
Yes.
Okay. So would you clear your board?
I'm gonna like this method.
And would you lay down your marker and your eraser and tune in? Because if you like this one, and you are definitely allowed to keep using this one, you might like the next one as well. Okay? Probably from now on, when we are comparing fractions where we can't immediately see, oh, they got the same denominator, they've already got the same numerator, and we can figure it out without writing anything, these are probably be the two strategies that we grab the most often. Okay? So I'm going to keep steal it and hide it. We're going to keep practicing it because even if you like the way I'm about to show you even better, there's going to be part of your problem set that I ask you to do steal it and hide it today just to practice it. Just so we don't forget it, okay?
I really thought I wasn't gonna like this.
So I'm going to move this on down. Yeah, I think I'm going to move it completely away for now. Okay. All right. So let's say, let me just grab another problem. I guess I could grab these. Okay. So we've got 2/3 and we've got 3/5. I'm going to erase this for right now. This method is going to make me draw through the center, and if you happen to draw through that bubble and it gets to where you can't, read because of all your lines, just make your symbol up here. Okay. So this method does not have some silly fancy story with it. It's just called the heart method. Okay. And this is why.
Oh, they're gonna love each other.
Okay. Got me? Okay. We're going to start here, and we're going to draw a line up to here and come around. And sometimes just drawing this confuses people because you forget where your lines are supposed to go, and so they like steal it and hide it better. But what is 5 times 2? 10. I didn't even write a fraction. I just multiplied. Now this 3 is going to go through that 3. Because what I'm doing is connecting them and showing myself what I need to multiply. What is 3 times 3? 9. Which of those two digits is larger?
10.
So if I did that, I would also need to do that. That fraction is larger. Now, wait a minute. I don't know about that. Let's just prove it with steal it and hide it. In case you're sitting there going, this is way too easy. Okay. If I have 2/3 and I have 3/5 and I use steal it and hide it, I would multiply both of these by 5. We stole the 5, we hid the 5. We stole the 3, we hid the 3. We would have 10/15, and we would have 9/15. See, what you essentially did was just find the numerator because you knew that the denominator was going to be equal. Can you see that, Caleb? And so this is larger, this is larger. Okay. So it does work with both ways. Nothing at all wrong with this, and this really isn't that slow, but you might like this even better. If you like this better, keep it, use it. If you like this better, keep it, use it. But I'm going to show you a few more examples of using it. Okay, I don't want to erase everything, but I'm going to slide it over. I'll keep that. Get rid of this. Okay. One more time, especially since this is fast. Won't take but a second. If we've got 5/3 and 7/4, and we choose the heart method, then you're gonna. Do y'all see why it's called the heart method? It kind of looks like a heart. That's why. Okay, that's why. Some of your problems on the problem set, the way they have printed it, the fractions are real out like this, and the heart looks really squished. So if you want to rewrite your fractions closer together underneath the problem, that's fine. But I'm going to draw a line to connect my 4 and my 5 because that's what I'm multiplying together. 4 times 5 is 20. But the problem that some people have had in the past is they forget that I got to stop right here and put that answer. Okay? Then I'm going to draw a line here from 3 to 7, connecting those, 21. See, these two fractions are very close in size. But 21 is larger, so 7/4 is larger. Now those, what kind of fractions are those? Look at them. Yeah. Those are improper fractions. Those are the ones that are larger than 1. But does this still work? Yeah. Y'all remember yesterday? We had a problem on our problem set and we skipped it because it was like, it looked like this. I think it was like 1 2/3. And I was like, oh, skip that one. We'll prepare for that later on. Okay. Because you have to change these into improper fractions for this method to work. Okay, so actually tomorrow we're going to be changing these into improper fractions. Okay, but it still works with improper fractions. Okay, let me let you try 1 or 2 with the heart method. Even if you like steal it and hide it better, I want you to practice the heart method just to get used to it. Yep.
This one's easy too because you could do this in your head easy.
Yeah. Even though I am going to ask you to show it. Okay? All right. So the fractions I'm going to give you are, this over here is just showing you what to do. Okay? 6/4, again, improper fraction. and 7/5. Okay. Now, you know what the hardest thing about the heart method is making sure my lines go through the right numbers and land in the right place. And, you know, just be careful. Okay. Give that a try. Okay, you think we've gotten it?
I don't know my multiplication facts. That's just good.
I'm telling you, at this point in 4th grade, listen to me. I hear Miss Terry talk all the time when I'm in 2nd period. You know, Miss Terry works with 5th grade and 6th grade. You know what she was telling those folks yesterday? She was almost fussing at them. She was like, if you don't know your multiplication facts right now, you better go home and practice. Get off that Fortnite, get off of whatever you're doing at home, and practice. No, she was very serious.
I don't play Fortnite.
Because your life is going to be hard, hard, hard if you don't get those like this.
I'm grounded.
You need to know them.
I can't play it.
Okay. It's time. It's time to know them because y'all know we've said it from the beginning of 4th grade. Multiplication and division, but multiplication is in everything we do almost. Okay. All right. So, what did you come up with for an answer, Valerie? Which of these fractions do you think is larger? 6/4 or 7/5?
7/5.
You say 7/5. Anybody agree with her? Yes or no? A little bit of a mixture? A little mixture. Let's check.
So which one's larger?
Yeah.
Oh,
You're saying 6/4?
6/4.
Okay. So let's check. Let's check. Because there was some mixture. If I do this, 4 times 7 is 28. See, the answer for that one is going to sit under the other fraction. Okay. 5 times 6 is what, everybody? 30. Okay. Yep, 30 is bigger than 28. So 6/4 is larger than 7/5.
Miss
Okay.
I messed up because I accidentally 28 was under 6/4 and 30 was under 7/5.
Now you knew what to multiply, or you knew the answer to the multiplication problem. You just put them in the wrong place.
Yeah.
Okay. So thank you for pointing out mistakes. Pointing out our mistakes helps everybody. So he has accidentally put his answers in the wrong spot, and I have seen that happen through the years. So be careful. That is the one thing I don't like about heart method. It's easy as long as you put everything where it goes. Okay? Because if I accidentally put this over here, I'm going to think this one is smaller and so forth. Y'all get what I'm saying? Okay. One more. There's one more left on one slide left. So let's try this one. Okay, and then we'll take our break before we we're going to use these methods. Your problem set might say use the area model. For today, I want you to use it to practice these 2 ways, and I'm going to tell you which method to do where. So right now, we've got 3/5, and we've got 8/12. All right, use the heart method to figure this one out. Okay. Try the heart method again. Let's see how this goes. Draw a line from the 12 to the 3. And the 5 to the 8. You have to go all the way up and draw through that number. Okay, so that you know you're multiplying 12 times 3. So that you know you're multiplying 5 times 8. Okay. So 5 times 8 is what, everybody? 40. 12 times 3 is what, everybody? 36. 40 is bigger, so that means 8/12 is bigger. Okay. You might have been thinking, hey, 12ths, those are tiny pieces. This is probably smaller, and it wasn't. Yes?
3 times 11 is 33. 34 times 5 is 36. Now just adding 31.
Okay. So you have a strategy for your 12ths. Gotcha. Okay. Yeah, now everybody's multiplication strategies are a little different. There's a lot of different things that help us that way. Okay. I think we're fairly comfortable with both of these ways. I am going to do this. I'm going to leave this so you have one problem that you can see with the heart method. And I'm going to redo this one with the steal it and hide it so that you can see that. And that way when you're working, if you forget what to do, you can look up here for those examples.
Are you going to put the one problem?
I'm going to go back one and do 6/4. You can go ahead and be putting your boards away. 7/5. Lay your workbook out, but we will start when we get back from our break. Okay. So this is steal it and hide it, where we steal the denominator and hide it. Steal that denominator and hide it. Okay. We'll talk about those in just a second. Let's put our masks on. Let's go ahead and line up. And we will use these as our examples. Those of you at home, work the problem set in the work the problem set for lesson 15 using these two methods, your steal it and hide it and your heart method. Okay, and you can choose which method you use where. Just be sure to practice both ways. You do not have to do the area model.